Today's lesson is on free fall motion, the motion of objects falling under the influence of gravity only. Say what? Yes, I said that. The only force acting on a free falling object is gravity. If you think about it, you're saying, wait a minute, as an object falls through the air, isn't there air resistance? Yes, you will be right. There is air resistance. But if the object is falling near the surface of the earth, if it's very close, we could neglect the effect of the air resistance. And thus, we could consider the motion as being free fall motion. The beauty of free fall is that any object falling near the surface of the earth, whether small, like a small rock, or large, like an elephant, has the same rate of acceleration, which is 9.8 meters per second square. That means if you start falling, you're falling at this rate. If the elephant falls, it falls at the same rate of 9.8 meters per second square. And that's if we neglect air resistance. If we have a vacuum tube in which we will place a rock in a feather, they will be falling at the same rate if we neglect air resistance. How fast does an object fall that is in free fall? Well, if the acceleration is 9.8 meters per second square, then the object is falling 9.8 meters for every second that goes by. What does this mean? This means that we can calculate the free fall velocity by using the equation v is equals to gt, where v is the velocity in speed, g represents the acceleration, gravitational acceleration, and then t is the time. We can easily compute this velocity after each second. Notice if there's no time on the clock, then it's not moving and the speed is simply 0. After 1 second, we have 9.8 meters per second times 1, which gives us 9.8. After 2 seconds, we have 9.8 meters per second times 2. After the 3rd second, times 3. After the 4th second, times 4. After the 100th second, times 100. So it is very easy for us to compute how fast it's going by simply multiplying 9.8 meters per second times the time. An object is said to be in free fall if gravity is the only force pulling it down. So that regardless of the mass of the object, it falls at the same time. For a bowling ball, which is approximately 71 newtons, a block, which is approximately 100, or a hammer, which is approximately 11 newtons, all of them will fall at the same rate. What if the object is rising and not falling? Does gravity affect it here too? Absolutely. Just as when the object is dropped, it speeds up by 9.8 meters per second, when it's thrown up, it slows down each second by 9.8 meters per second. Galileo proved this in his experiment from the Tower of Pisa with one 10-kilogram cannonball and one 1-kilogram stone, and he saw that they struck at the same time, regardless of their weight. How is this? Well, it is simple. The bowling ball, which has a large force acting on it divided by the large mass, is going to be the same as the force acting on a small rock divided by the small mass. Notice that the ratio big force divided by big mass is the same as the little force divided by the little mass, which is equals to g. The ratios of the weight to mass are identical, and therefore we get the same value each time. This is all for our free fall lesson. I hope that you enjoyed it.